Welcome to AJT Chemistry channel. This is the second part on the questions on the stability of carbocations. I request you first go through the first part, then you can understand second part very easily. The fourth question is again, arrange the following in the order of stability. I told you first you have to look at whether resonance is possible. Then first question is this one, second one is this one, third, fourth. Pause button and try to do yourself and then goes to the discussion. Here you can see that whether the resonance is possible or not. Plus oxygen is there. You know, the valence electron of oxygen is 6. Out of 6, 2 electrons are take part in bonding. The rest is there. Here again, oxygen. You can find that this lone pair is in conjugation with the plus. Therefore, resonance is possible. That is just like this way. This goes to here. This can jump from here. Resonance is possible. Here also, resonance is possible. Here there is no resonance, only plus charge. There is no resonance. So the most stable structure should be either this one or this one. After looking resonance, you have to go to the hyperconjugation. This is our system now under consideration. Here the system is just like this way. So alpha carbon, alpha carbon, alpha carbon, alpha carbon, alpha carbon. Here 3 alpha H, 3 alpha H, 2 alpha H, 3 alpha H, only 1 alpha H. Here in both cases resonance is possible, and in these cases 3 plus 3 plus 2 you will get 8 alpha hydrogen. Highest number of hyperconjugation is also possible, therefore this should be the most stable. Therefore 1 is higher than. Then you goes to this one because this also have resonance 3. Out of this is alpha carbon, this is alpha carbon, this is alpha carbon. But 2 alpha hydrogen, 3 alpha hydrogen, 5 alpha hydrogen, only 2 alpha hydrogen. Therefore the next is that is second one, and finally it is fourth one. This is the fifth question. The question is that total number of contributing structure due to hyperconjugation in the following molecule is. The question is that one. That is asked in 2011 advanced IIT JEE examinations. This is very simple, you know. This is the carbocation, most important position. You taken it as alpha carbon. Now this is alpha carbon. Then this is again alpha carbon. This alpha carbon have 3 alpha hydrogen, just like this way. Therefore it can exhibit hyperconjugation. These 2 electrons jumps to here. Due to this becomes double bonds. Next time this jumps to here, this jumps to here. When you look at my lesson on hyperconjugation, you will get a clear picture. Here total 3 alpha hydrogen, 2 alpha hydrogen. Here only 1 alpha hydrogen because the valency of carbon is 4. 3 bond is already there. Only 1 hydrogen will be there. Total 3 plus 2 plus 1, that is 6 alpha hydrogen. All this 6 alpha hydrogen will contribute this hyperconjugated structure. Therefore we can say that there is 6 hyperconjugative structure is possible in this molecules. Next question is, which of the following is most stable? As a question. So you know, nitrogen have lone pairs, oxygen also have lone pairs. Therefore lone pair, single, double conjugation is possible, resonance is possible. Lone pair single plus, lone pair single plus, again resonance is possible. So which will contribute more towards resonance? That is our questions. You know, the electronegativity of oxygen is high than nitrogen. Therefore The lone pair of electron of oxygen have less tendency to goes to this bond than nitrogen. Therefore, the more chance of movement of electron is high for nitrogen than oxygen. Therefore, the tendency of resonance is high for nitrogen than oxygen. Therefore, this should be higher than, more stable than this one. Get the idea? Right. One more different types of questions regarding the stability of carbocations. The question is arrange the following in the order of stability. How can we answer it? I look at it. First, you have to look at in which molecule resonance is possible. Here there is no resonance. Here there is resonance is possible because plus is in plus, single, double, single, plus are in conjugation. Here also resonance is possible. Plus, single, double, single, plus. Here also resonance is possible. Plus, single, plus, double, single. You can see that. The one more thing is that after looking the resonance, you have to consider in the case of cyclic compound whether aromatic or not. In the cyclic compound, the peculiarity is that if it is aromatic, definitely it will be highly stable. Then non-aromatic, and finally anti-aromatic. Anti-aromatic is least stable. You know, for aromatic compound, the number of delocalized or circulating electrons should be either 2, 6 or 10. I've already given a lesson on this one. If the delocalizing electron is 4, 8, 12, that is foreign number of electrons, then it is anti-aromatic. Anti-aromatic is highly unstable also. Therefore, in this answer, here 2 pi electron is there, that is undergo delocalization. 2 pi electron system. This is a 2 pi electron system. Here 1, 2, 3, 4. There is no electron. These are undergo delocalization. This is a 4 pi electron system. It is a 2, 4, 6 pi electron system. You know, 6 pi electron system and 2 pi electron system is aromatic. 4 pi electron system is anti-aromatic. Since most number of delocalization is here, we can say that if you take it is 1, 2, 3 and 4, you can say that 4 is the most stable because aromatic, most number of electrons delocalizing, it is most stable. Then 2, it is because it is again aromatic. Then here there is plus charge, no aromaticity, no delocalization, etc. Here instead of aromaticity, it is anti-aromatic. I told you anti-aromatic is highly unstable. Therefore, only after this man comes. That is how the order of stability. Get the idea? Right. Okay. 9th questions. Arrange the following carbocations in the order of stability. That is the questions. I told you on giving you the answers. First, this is first one. Write down. Second one. Write. Third one. Fourth. Fifth one. We have to arrange them in the order of stability. Press the pause button in your video and then try to do yourself. After that, you come to the explanations. The explanation is that I told you first you have to look at whether resonance is possible or not. Your lone pair is there. Oxygen have lone pairs. It will not be given in the questions, but you have to keep in mind that oxygen always have lone pairs. These lone pairs and plus charge are in conjugation. Therefore, resonance is possible. Lone pair, single, double, single, plus. Therefore, this whole system are in conjugation. Now here, lone pair plus single, double. This whole system are in conjugation. Here, lone pair and plus. This is the conjugated system. Here, lone pairs, single, double, single, plus, completely in the conjugated system. So, on looking these questions, we will get the answer that Here is the most number of conjugation. Definitely, this is the most stable. That is, fifth is the most stable carbocation in the given questions. Then this one and this one have equal number of conjugation. But you know, if equal number of conjugation, the next point you have to look at the hyperconjugation. Here, this is taken as alpha carbon. This is again alpha carbon. This is taken as alpha carbon. This alpha carbon have 3 alpha hydrogen. Here 2 alpha hydrogen. Total 5 alpha hydrogen. Here only 2 alpha hydrogen. 2 alpha hydrogen. Therefore, the next is nothing but number 3, which is higher than number 2. And next, this one and this one, 1 and 4th, which will be stable. It's very simple. Here you can find there is an alpha carbon. Therefore, this have 3 alpha hydrogen. Such type of alpha hydrogen is absent here. Definitely, next one is 4th, which is higher than, and the last one is, that is, 1st. Next question. Arrange the following in the order of stability. Similarly, you can say this oxygen have lone base. Lone pair, single, double, single, plus. That means these whole are in conjugation. This is taken as our system under consideration. Here, lone pair, single, double, single, plus. This is our system. This is our system. Right. Now here, lone pair, single, plus, single, double. This is our system. This is our system. Now here, this is our system. Now come to the answer. You know, this one and this one have a equal number of conjugation. 2 double bonds, 2 double bonds. Lone pair, plus, 2 equal number of conjugation. Now you have to look at the number of hyperconjugation or number of alpha hydrogen. Now, since this carbon is attached to this system, this is, you can take it as alpha carbon. This again alpha carbon. Here only this is alpha carbon. Moreover, this is again, you can take it as alpha carbon. Right. So total 3 alpha hydrogen and 3 alpha hydrogen. 6 alpha hydrogen is there. Here no alpha hydrogen. No alpha hydrogen. Therefore, we can say that the most stable is number 2. Resonance is the, moreover, highest number of alpha hydrogen. Higher than number 3. Here the most number of resonance, that is number 3. Higher than. Of course, this one, because more than this have more resonance than this one. Therefore, number 1 higher than number 4 is the answer. Right. This is another type of questions. All are carbocations. First of all, you write down these questions in your paper. This one, NO2 group is the, chlorine is the, methyl group and OCH3 group. I told you that if there is any factor that increases the positive charge on the carbocation, destabilize the carbocation, or any factor which decreases the positive charge on the carbon atom, increases the stability of carbocations. If so, look at how NO2, chlorine, CH3 and OCH3 affect the positive charge on the carbocation. You know, NO2 group have a minus R effect and also minus I effect. These things already I discussed in the part 1 of on my video, minus R effect and minus I effect, and hence the total is it have a EWG, that is electron withdrawing effect. Chlorine have a plus R effect and minus I effect. Therefore, plus R effect and minus I effect, but here inductive effect is little bit stronger than resonance effect, and the net effect is again EWG, electron withdrawing group. Chlorine is again electron withdrawing groups. CH3 have a plus I effect and also have a hyperconjugation by of CH3 plus I. That means electron donating groups. All CH3 have a very high plus R effect and very small plus I effect, and the net effect is that is again electron donating. It is EDG group. It is again EDG group. Here the EDG effect is due to the plus R effect. Here EDG is due to plus I effect. Here EWG is due to very small higher minus I effect. It is minus R effect and minus effect. Both are have EWG group. So we can say that if this NO2 group is present, you can see that the shared pair of the electron will be pulled from this CH2 plus. Definitely the positive charge on the CH2 plus increases. It get destabilized. But here EDG groups, it push the electron towards this one. Therefore, the positive charge on the CH2 plus decreases. So we can say that on looking these values, you can say that if it is taken as 1, it is taken as 2, it is taken as 3, and it is taken as 4. The most stable will be 4 due to very high plus R effect that decreases the positive charge on the CH2 plus. Next one is this man, that is CH3, because it again have plus I effect. Therefore 4 higher than 3 higher than. Next is that is this one, that is 2 higher than 1 is the answer, right? Okay. So here plus I and hyperconjugation is present. So the competition is between this man and this man. Competition is between this one and this man, because in both case plus I and hyperconjugation and plus I and hyperconjugation. You know, this plus I effect, the intensity of the plus I effect decreases with the distances. Therefore, CH3 group is very near to CH2 plus. Therefore, the plus I effect due to this CH3 group is high in this case than in this case. Definitely, we can say that this can produce very high plus I effect. That is plus I effect just like this way. Definitely, the intensity of the positive charge increases much high here. Definitely, we can say that second is more stable than fourth one. Here there is again plus I effect. Therefore, third one, here there is no such plus I effect. There is no methyl group. Then this is the last one, that is second higher than 4 higher than third higher than 1 is the answer, right? Okay, right. This is the next questions. Look at the answers. You know, CH2 double bond CH, CH2 plus, CH3, CH2, CH2 plus, CH2 double bond CH, CH2, CH2 plus is the question. First you have to look at whether resonance is possible or not. Here or no, plus single double resonance is possible. Here there is no resonance, only plus, there is no resonance. 2 alpha hydrogen is there. There is a plus I group is there due to methyl group. Methyl is a plus I, or ethyl incompletely you can take it as it is a plus I group. Now look at here, these molecules. Plus, single, double. That means this plus and double are not in conjugation. Therefore, no resonance. Therefore, it have the resonance. Definitely, we can say that 1 is the most stable. If you take it as 1, it is 2, it is 3. We can say that 1 is most stable carbocation. Next is 2 and 3. You know, this group, I have already told you that alkenyl group have a minus I effect. Therefore, it will pull the electron pair from CH2 plus. Definitely, the positive charge on the CH2 plus increases, destabilize it. Therefore, it is the most unstable. Here, this have 2 alpha hydrogen due to this hyperconjugation is possible. Moreover, it have a plus I effect. Due to plus I effect, the positive charge on the carbocation decreases. Therefore, we can say that 1 is more stable than 3. Right? These are some questions. These are some examples I have did to find out the stability of carbocations. Now I am going to stop here. Then I will give you few more questions that you can do yourself. After getting the answer, you can contact me in my WhatsApp number. I will give you the clarification. Okay. Now let us look at what are those questions. Right. These are the questions for your self-assessment. Look at this question. First question. You draw that question. This one. Okay. Arrange them in the order of stability. Question number 2. Arrange them in the order of stability. Question number 3. A NO2 group is present at ortho position, meta position, para position. I told you the resonance effect is important only if the groups are present at ortho and para position. That is a hint for this question. Moreover, that is hint. Right. Okay. Fourth questions for you. Stage 3, stage 2, stage 2 plus. Stage 3, N, stage 3, stage 2 plus. Stage 3, stage 2, stage plus, stage 3. A, this is B, this is C, this is D. Tertiary butyl carbocations. Arrange them in the order of stability. And the last question for your self-assessment. Among P, Q, R, which of them are aromatic? This compound, on reaction with AlCl3, P is formed. My question is that, is this P is aromatic or not? It's a clue for you. Aluminum trichloride is a Lewis acid. It's electron deficient. So, such type of reaction only you have found. NaH. This molecule on the action with NaH will get a product. Again, NaH have the power to abstract H plus, that is the heat. This is 7-numbered compound. To this H plus have to be added. We will get R. My question is that whether R is aromatic or not. You find out your own answer for these questions. If you have any queries or any doubts, or you can share this answer with me through this number 9387849592 through my WhatsApp contact. That is how the stability of carbocations. I have published already one lesson on carbocation. This is second one. I request you, if you understand these things very clearly, first you have to look at part 1 and then go to part 2. So in coming days also I will publish few more lessons on different parts. So I request you that if you wanted to quickly access that videos, please subscribe this channel. The name of this channel is AJT Chemistry. Thank you.